Fourth lesson in Chapter 2 is Statistical Graphics. The main part of the statistical graphics here is, yes, we want to know how to create them, but more so we want to know how to read them and what information can we gather from these statistical graphics. We're going to go through several statistical graphics and we're going to talk about what they can display and how best we can use them. First of all, our objective with any statistical graphic is to show any results in a statistical analysis. We want effective representation, and the important characteristics of any statistical analysis should be highlighted, and we highlight that through the different types of graphs that we choose. We also have to figure out that, is the data that we're getting appropriate? Is it most effective to showing the data? If we only, or if we're trying to compare two things and they have different populations, maybe we want to go straight to percentages and a pie chart as opposed to a frequency distribution, because someone would argue that the sample sizes are off. There are things that we need to hide when we're doing certain things. First, let's talk about the frequency polygon, which in reality is just a line graph. We take line segments and connect them to points directly above the class midpoints. We use the class midpoints for a line graph, and you can see the example there below. You have the frequency on the left side and class marks on the bottom there. The relative frequency polygon is what we'll use when we're trying to compare two things at once. The example that you'll see on the bottom is ages of your best actresses and actors. Could come from the Emmy or Grammy Awards, but that's how we would measure something like that, and we can easily compare them by doing the relative frequency, by using a percentage. There might be more actors than actresses, so it's important to use a percentage there. An ogive, this is something new. An ogive is a line graph that depicts a cumulative frequency. You can see the one at the right. Obviously, if it's depicting a cumulative frequency, we want to see the line graph going up at not at a constant rate, but always going up. Again, the graph is called an ogive. A dot plot is similar to a stem and leaf plot, except we're just creating dots. And what we want to do is, for every time that, for example, on the right there, every time that we see a random value of 0, we put a dot in. So you can see that there were 3 0 random values. And we basically do it along a number line, and we can plot dots where need be. In the case, if we had decimals in this case, we could plot them in between the two units if we had to. Stem and leaf plot is something familiar to you from integrated algebra. It represents quantitative data by separating two values into two parts, and typically this is to show distribution. As you can see on the right, the stem and leaf plot of ages of people at a family reunion, you can see the distribution of ages and the fact that most of the people are under the age of 40. Here's just a couple of examples of bar and multiple bar graphs. I don't want to get too much into them. You know what bar graphs do. They show frequency. They're a little bit different than histograms, that we're typically not having intervals on the bottom of bar graphs. It's typically qualitative data mixed with quantitative data. Multiple bar graphs show great comparison. You can see in the one at the right, we're comparing different types of cookies along with their different years. So multiple bar graphs are also helpful. It's kind of like having mini histograms in one spot. A Pareto chart is a bar graph or histogram, can be either one of the two, that shows qualitative data. There is an added stipulation to that the bars are always rearranged in descending order, as you can see to the right. We rearrange the bars, you rearrange the data so it's always in descending order. A pie chart is one that will depict qualitative data, and it uses sectors of circles to show proportionality, or it shows percentages, and that is where we have the frequency count. This particular pie chart is a comparison with Wii, Xbox, and PlayStation, and the percentages of people that use them. One of the things I don't agree with in this particular graphic is that they put the numbers of people instead of the percentages. Pie charts are typically reserved for percentages or proportions. Scatterplot is also something that you're familiar with. That's when we compare two sets of quantitative data and we graph them as points on an XY coordinate plane. Typically what we'll do with a scatter plot as well is after we graph all the points, we'll take a look at the regression equation and find what the best fit equation is, or the best fit straight line, if it's going to be a best fit quadratic, etc. The last one is the time series graph. The time series graph is exactly what its name suggests. It's showing quantitative data as it is collected over time. The big one that this is used for is radioactive material. Those of you that are interested in chemistry, you've seen time series graphs plenty when it comes to radioactive decay. Homework in this section is going to be textbook pages 67 to 68, numbers 1 to 4 all, and 5 to 15.